Good afternoon and welcome to webinar number 3 in the series of webinars presented for the VA 215 class, the Business Statistics class. My name is Denise Williams and I'm a tutor that works with the Math Center at Grantham University. I will be presenting today's webinar. Now let's get started. The webinar is entitled Using Technology in Business Statistics, and basically what we are going to be doing is running through Microsoft Excel and explaining how we can use Excel's formulas and functions, as well as the analysis tool pack add-in, to help us to perform statistical analysis for our BA 215 class. Now today's topic is finding the area under the standard normal distribution. Finding the area under the standard normal distribution. Now, there are some vocabulary words that we're going to be using today intermittently, and so just to make sure that you understand what we're doing and that you're able to follow along, we will speak very briefly about each of the vocabulary words. Now, the first word that we're going to talk about today is the normal distribution or the curve. Now, in this week 3 of your statistics course, you are asked to talk about random variables, and one of the continuous random variables is associated with the normal curve. Now, underneath this normal curve, we're able to find percentage and percentages and proportions that are associated with the area that is under the normal curve. In a minute, I will show you a graph to help you to visualize what we're talking about. Next, we're going to talk about the standard normal curve. Now, the standard normal curve is a extension of the normal curve, except that it has particular criteria that have to be met. In particular, the normal curve has any mean and any value for the standard deviation, but the standard normal curve must have a mean that is equal to 0 and a standard deviation that is equal to 1. In addition, while the normal curve works with the variable x, the standard normal curve almost 100% of the time is denoted by the random variable z, denoted by the random variable z. So we're going to differentiate today between the normal curve and the standard normal curve. Finally, we're going to talk about z-scores. Now, what z-scores are a measure that are used with the normal graph and the normal curve to talk about the deviation from the mean. How far away is a data value from the mean? How far away is a data value on the graph from the mean that is in the center of the graph? This is referred to as z-scores. Now, if there's anything that you don't understand in association with these vocabulary words today, please make sure to review this section in your textbook, or please see the Math Center or your professor for any additional help. Now we'll begin. Here is an example of a standard, or here is a graph of the standard normal distribution curve. Now please note what is identified or identifying factor of the standard normal curve. In the middle of the graph is the mean value. In the middle of the graph and along the x-axis, we see a 0. Now this 0 is the mean of the standard normal curve. That means the average value for the standard normal distribution is going to be equal to 0. In addition, another identifying factor of the standard normal curve is that the standard deviation, here denoted by sigma, the standard deviation is always going to be equal to 1. The standard deviation is always going to be equal to 1. Now here on the standard normal curve, which is also called the bell curve, we see that the data is in increments of 0.5 deviations away from the mean. Most of the time we focus on the data that is between 1, 2, and 3 standard deviations of the mean. Within 1 standard deviation of the mean, we have 68% of the data, and this you can verify by adding up the numbers that are course, that are there. The 15%, 19.1%. If you add those four numbers up together, you will come up with approximately 68%. Between two standard deviations of the data, we have approximately 95% of the data. Between two standard deviations of the data, we have approximately, between two standard deviations of the mean, we have approximately 95% of the data. And so we can verify this by adding up the 4.4%, the 9.2%, 15%, 19.1%, and so on. This will give us approximately 95%. Now, if we go further out, another standard deviation in both directions, we'll come up with three standard deviations within the mean, within three standard deviations of the mean. Within three standard deviations of the mean, we find almost 100% of the data, 99.7% of the data. Now, for this reason, because most of the data is concentrated between -3 and +3 along the x-axis, within three standard deviations of the mean, most bell curves, and the ones that we will be using today, most of them are along the x-axis, go out only to about 3, a little bit more than 3 in the positive direction and -3 in the negative direction. Now, this is an introduction to the standard normal curve, which is what we're going to be working with initially. Now, this class is a Excel data analysis tutorial class or a tutorial webinar. So we're going to focus on today how to use Microsoft Excel to find the area that's associated with a normal curve. Now, if you did not use Excel, what would you have to do? If you're given problems that appear similar to the ones that are on your screen at this moment, for example, number 1, the area to the left of Z, the area to the right of Z, the area between Z, and finding the Z-score, if we're given a particular value of Z, now how would we solve that? If we did not have Microsoft Excel, we would have to use the table. Most statistics books have a normal distribution table that is in the back of the book or inside the textbook in some place on some page. And if you are using the textbook from this year, it's within the pages. There are also many, many normal distribution tables available online. Now, normal distribution tables are very good. They're wonderful to use. They're easy to use, and the book explains how to use them. But today, again, this is an Excel tutorial, and so we're going to focus on how to use Microsoft Excel to answer the questions that are on the screen. Now we're going to take them one by one. The standard normal curve, again, talks in terms of Z. Here we have a mean of 0 and a standard deviation of 1. Now, if we're asked to find the probability or the proportion that is associated with an area to the left of some value, so if you look on your screen and you see where the arrow indicates, the arrow that is indicating along the x-axis, now that arrow indicates some value Z, some value Z. Now we're trying to find the probability that Z is less than that value, the probability that Z is less than that value. So we're trying to find the area to the left of Z. Now, if we're trying to find the area to the left of Z, there's a formula or function that we can plug in directly to Microsoft Excel, and that formula is listed on the screen. Here we're going to type in norm, N-O-R-M, dot S dot D-I-S-T, open parentheses, Z, comma, true. In this case, true. Now, this S, let's talk a little bit about that S. Now, what that S stands for is standard. That S stands for standard. Remember, initially we said that there are two different normal curves. There's one that is a regular normal curve, and then there's a standard normal curve. Now, if we are working with Z-scores, we already know that our data is normalized, it's standardized. It's standardized. Now, we would use this formula to make sure that you have the S between the norm and the DIST. Now, if we have this formula, we can find the area to the left. The area to the left is indicated by the shaded portion that is pointed to by the second arrow, the arrow at the top. Now the shaded portion, the portion to the left of the line, is the probability or the proportion. And this formula gives us the area of the shaded region. Now, what if you were asked to find the area to the right of some curve? What if you were asked to find the area to the right of some curve? Now, if you're asked to find the area to the right, you have to do a little bit of tweaking to the formula that is given in the previous slide. The area to the left is equal to 1 minus the area to the right, or the area to the right is equal to 1 minus the area to the left. This is due to the symmetry of the normal curve. They are mirror images of each other. We won't talk in any greater detail about this, but just know that if you're trying to find the area to the right, so in this example, the blue area that is shaded is the area to the right of this line here. Now, if we're trying to find that, we are going to apply the same formula that we used in the previous slide, but here we're going to take 1 minus that formula. 1 minus that formula. Notice again that we're going to put in an S in the middle of the norm and the dist. This cumulative, in a minute we're going to show you an example. This cumulative is not what you will type. Instead, you're going to type true or false. But because we're trying to find an area, in all cases, we're going to write true. This cumulative, you will write true, T-R-U-E. Now, what if you are given 2 points on a curve, 2 points on the curve, and you're asked to find the area in between those points? Now, look at the graph that's indicated here, the graph that's shown here, and we're trying to find the area of the blue portion, the shaded portion that's given here. Now, if we're trying to find the area, again, we'll have to do a little bit of tweaking, or at least we're going to have to do a little bit more work than we did in the first graph, with the first graph. We are going to take the normal distribution formula, but instead of putting both of these numbers in at the same time, we have to take the larger number. In this case, B is the bigger number. We put that in first, comma, and then we're going to write true. Then from that, we're going to subtract norm.s dist, the A, which represents the smaller number, comma, true. Now, if we plug this into our Excel, remember that we put the equal sign in before them, we are going to come up with values that represent the area of the indicated portion, or the area of the shaded portion. Now, let's see if we can do some examples, and then we're going to come back and talk about something else. Now, there are 8 problems that we're going to try and do. The first problem is the area to the left of Z is equal to negative 1.04. The second problem is the probability of Z being less than 1.19. Now, although these problems are written in a different way, the first one is written with many words, and the second one is written as a probability. They're both asking for the same thing. They're asking you to find the shaded portion to the left of that Z value. In problem 1, the Z value is negative 1.04. And problem 2, the Z value is 1.19. Now let's go ahead and go to our Excel spreadsheet. So if you have Excel, please open it now. Microsoft Excel, open it now. Now recall that we're trying to find, for the first problem, we're trying to find what is equivalent to saying the probability that Z is less than negative 1.04. For this problem, this is equivalent. The area to the left of negative 1.04 is equivalent to saying probability of Z being less than negative 1.04. Now, given that this is a problem that we're trying to solve, How do we, see if I can make this a little bit bigger. How do we solve this first problem? Now recall that we're trying to find the area to the left. And if you've written down the formulas, then you'll remember that the formula to find the area to the left is equal to norm dot s dot dist. Now the next thing that we're going to have to type after we open our parentheses is the z value. Now from this particular problem, the z value is given as negative 1.04, comma, and then we're going to write true because it's an area. So our answer very simply is 0.14917. 0.14917. This represents the area to the left of negative 1.04. Now let's try it again. The next problem, number 2 that we looked at, it asked us to find the probability of z being less than 1.19. What's the probability of z being less than 1.19? Now for this particular problem, again, we're going to type in the equal sign, and then we're going to type norm.s.dist, open parentheses, and we're going to type in the 1.19, comma, true. Press enter, and this gives us the area to the left of 1.19. The area to the left of 1.19. Now let's go back to our presentation. The next problem asks us to find the area to the right of z point of 2.04. The area to the right of 2.04. The fourth problem asks us to find the area to the right of 1.61. The area to the right of 1.61. So let's go back to our Excel spreadsheet and see if we can find these. So problems 3 and 4 are asking essentially the probability that z is greater than 2.04 and the probability that z is greater than 1.61. Now for the first one, the probability of z being greater than 2.04, again, this takes a little tweaking. We're going to say it's equal to, don't forget the equal sign, 1 minus norm dot s dot dist, open parentheses, and then we type in the 2.04, comma, true. We do the same thing for problem 4. We equals norm dot s dot dist, open parentheses, 1.61, true, close parentheses. Now this is not right. Remember, I'm supposed to subtract from 1. So this is my correct answer. Now what if we are trying to find the area between two different numbers? So not only less than, but also greater than. We have two different things that we need to work on. It's between two different numbers. Now if that's the case, let's go back to our presentation and we can look at problems 5 and 6, 7 and 8. Let's focus on number 5 and number 7 for now. Number 5 and number 7. So we're asked to find for problem 5 the area between negative 0.34 and 1.03. So on the graph, on the x-axis, there's one negative number, 0.34. Then we go along the graph, continue until we get to 1.03. We draw little tick marks at those points. Now, whatever is between negative 0.34 and 1.03, we're going to shade. We're going to shade it in a different color, gray or blue, similar to what we have seen in the graph before. Now, once we've shaded that area, we're trying to find out what that proportion is or what that probability is that corresponds to that area. So let's go ahead and do that in Excel. So I said that we're going to do number 5 and number 7. Number 5 is asking us the probability, open parentheses, of z being between negative 0.34 and 1.03. While we're at it, why don't we just look also to see, we just write down probability for number 7 of being between 1.21 and 2.28. Now for number 7, this is actually number 5. For number 5, remember we type in according to the formula that was on the PPT slide, the keynote slide, we're going to type in the formula for the normal distribution that we've been using, but we're going to first use the larger of the two numbers. So we're going to type in normal.s.dist, open parentheses, 1.03 true, minus norm.s.dist, open parentheses, and then the smaller number, 0.34 negative, true. And this number, 0.48157, represents the area in between those two values. Let's try it again for the second. Norm.s, forgot my equal sign, norm.s.dist, open parentheses, 2.28, true, minus norm.s.dist, open parentheses, 1.21, comma, true. And that gives me 0.10184. So again, what does this mean? We draw our normal curve. So we have our normal curve that looks something similar to this. And along our normal curve, along the x-axis, this x-axis here, we're looking for the numbers. We're looking for some numbers. Now, when we find those numbers along the x-axis, we're going to draw tick marks there. And then we're going to shade the portion that corresponds to that. Once we shade the portion that corresponds to that, we look for the area. We can look for the area using the table, but we have just shown how to find that area using Microsoft Excel. Now, the next step is if you are already given the area. Now, how do you find the corresponding z-score? If you are already given the area, the value for the shaded portion, how do you find the corresponding z-score? So let's look at this. Let's go back. Now, here we are given a area. So the shaded portion that's on the screen, the shaded portion is already given to us. And we're asked to find the z-score that corresponds to that shaded portion. In a minute, we'll give an example of why we would ever have to do that. Now, if that is the case, though, we can't use the same formula that we've been using, because those formulas tell us what the shaded area is if we're given the z-score. But now we don't have the z-score, so we can't use that. Instead, there's another built-in formula function in Excel, and that is called the norm inverse. Now, the norm inverse tells us the value that is given, the value that corresponds to the given area under the curve. Norm inverse, we're going to type in. Notice that this also has an S. The S is because it is a standard normal curve. And then we're going to put within the standard normal curve the area to the left. This is important. The area to the left is what we're going to plug in. In fact, I'm going to write that again so that you don't get confused. We're typing in the area to the left. Okay, now let's see some problems. So an example of a problem that would ask us to do that is number 9 here. Number 9. We're asked to find the z-score such that the area to the left of the z-score is 0.84. So they're giving us the area to the left and they're asking us to find the corresponding score if we know the area to the left. So we're going to go back into our Excel and see how to find that. First, I'm going to write out what the probability corresponds to. What does this actually look like? Now, if we have, if we're trying to find what I just said, this means that we're going to have the probability of z less than or equal to some lowercase z. They're the same letters, just one is big and one is small, is equal to 0.84. And what you're trying to find out is what is z equal to. The little z, not the big Z. Now, again, we go to our function and we're going to type in norm.s.inverse because it's a standard normal. Open parentheses, and we're going to put in the area to the left, which is 0.84. Close. Now, what does this mean? This means that if we go to the number 0.99446 on our x-axis, and then shade the area to the left of that number, the area to the left of that number is equal to 0.84. The area to the left of that number would be equal to 0.84. Okay, so hopefully that was pretty straightforward. And what I'm going to do is show you how to set this up in a table format. Well, this is pretty easy to do. We just type the same functions over and over again. Normal.s.dist, the area or the z, and then comma true. But when you have many functions to do, similar to your homework problem, you have many functions to do, perhaps you don't want to continue typing in this formula. So what I'm going to show you how to do now, is set up the table, to set up a table. Okay, now what we see here, we're going to make this bigger as well. What we see here is a table that I have set up. Here, the area to the left, we're going to calculate that. Here, if we are trying to find the area to the right, is where we would calculate this. And then the area in between two values, we would calculate here. All right, let's get to it. So the area to the left. Now here I'm going to write I've set up a table, and in this column I'm going to have my z values. In this column, I'm going to have my probability formula. So the probability formula says, first, if I'm finding the area to the left, first I type in the equal sign after clicking on an empty cell. Then I have norm.s.dist, open parentheses, this value z, and then true. Now, don't pay any attention to this 0.5 at this moment. This formula says whatever value I plug in for z, it's going to give me here the area to the left. Now, what about the area to the right? Again, remember the formula is first type in the equal sign, and then 1 minus norm dot s dot dist, open parentheses, this value, true. And this will give me the area to the right. Now, what if I'm trying to find the area in between? If z1 is a smaller number and z2 is the larger number, remember, z1 is a smaller number and z2 is the larger number, I'm going to type in norm.s.dist, open parentheses, the larger number, comma, true, minus the same formula, but this time using the smaller number, comma, true. If I'm trying to find the z value when the area is given, this time the area and the z. This is equal to norm.s.inverse, open parentheses, the area to the left, close parentheses. Ignore this for now. We'll see soon what to do. Now let's go back to the original problems. Numbers 1 through 9. They're all dealing with z-scores because they're all dealing with the letter z. Now, the first one we've already done, but we can do it again. The area to the left of negative 1.04 and to the left of 1.19. In fact, we're going to do all of the problems here, 3, 4, all the way through 9. So take note of them. Let's go back to our Excel spreadsheet. Now for the first one, the area to the left, all I have to do, because I've already typed in the formula here, all I have to do is plug in the z value. So for number 1, the z value is negative 1.04, which gives me a probability of 0.145, which is what we had already found. Remember the formula that's here is norm.s.dist, and then instead of actually typing in the number directly, I've typed in B2, which is any value that ends up in this cell. Now, what if I want to find number 2? Number 2 asks me for the probability of it being less than 1.19. Now that gives me an area of 0.88298. This is for problem number 2. Now problem number 3 asks us for an area that's greater than 2.04. Similarly, I've already typed in the formula here, but notice that instead of typing in the number directly, I clicked on an empty cell where I can later change my z values accordingly. And instead of having to type in the formula over and over again, the formula will on its own update itself. So for problems 3 and 4, I'm asked to find the probability of z being greater than 2.04 initially, which gives me this value. For problem 4, I'm asked to find the probability of z being greater than 1.61, which gives me this value. Now for problems 5 through 8, they're asking us to find areas in between the curves. between the values. So Z1 and Z2 are two different numbers that we're going to have to type in. Remember that in Z1, I'm asking you to please put in the smaller number, so negative 0.34 for problem 5 is the smaller number. And then 1.03 is the larger number. What does this give us? It gives us a probability value of 0.48157. 0.48157. So this is our area as corresponding to the area that is between those two values. We can do that again for problem number 6. For problem number 6, we're asked to find the area between 1.93 and 3.93. Again, notice that the area, that the smaller number is represented for the first column, and then the largest number is represented in the second column. Now we can continue to do that for number 7 and number 8. Let's go ahead and do them so we can check our answers. 1.21 and 2.28. For problem 8, we have 0.21 to 1.69. So we have a value of 0.37132. So that is the last thing before the very last thing. So the penultimate. Now the next thing that we want to do is we want to find the z value if we've already been given the area. This is very similar to the problem. This is actually the problem, the last problem that we have on the sheet, problem number 9. Now we're trying to find the probability that z is less than some z score, some z value. And that value is already given. The area has already been given to us. So that is area is equal to 0.84. Remember our formula, norm.s.inv. And then instead of directly typing in the number, I've typed in a cell, an empty cell, so that I can keep on updating it. Now notice all of the z's. All of the z's. Now all of the z's indicate that we are dealing with a standard normal curve, Now, this is pretty much the extent of what is discussed in your course for BA 215, standard normal curves. But it's also beneficial to learn about the application of these things. So we're going to do now 2 problems using the tables that we have set up, 2 problems that talk about how to use the information that we have just learned. Let's go back to our keynote. Now, when we are dealing with real world data, we are not dealing most of the time with standardized data where the mean is equal to 0 and the standard deviation is equal to 1. So what formulas then do we have to use if the data is not standardized? Now we're going to look here on the screen and we see that there are many formulas. The area to the left, the area to the right, the area between values, and then area given, find the value given area under the curve, and finding z values. That one, the last one, we're not going to talk about, but you can have it for reference. Now I'm actually going to change some of these formulas. They're not wrong in and of themselves, but I just don't want you to get confused. So I'm going to change all of the areas, all of the places that say cumulative, I'm going to change them to true. And where it says probability, I will change it to area to the left so that you don't get confused. So let's see how to use these formulas. So notice throughout the formulas that are listed here that there is no S in between the norm and the dist. There's no S in between because it is not standardized, and that S stands for standardized. Also notice that the formulas are a little bit more complicated or a little bit more detailed in that you have not only to put in your value, along your x-axis on the normal curve, but you also have to put in the mean and the standard deviation. Because the mean is not assumed to be 0 and the standard deviation is not assumed to be 1, you will have to put in these values. But every other thing remains the same. The Excel formula gives you directly the area to the left, but if you're trying to find the area to the right, you'll have to subtract from 1. If you're trying to find the area between two values, we'll have to subtract the smaller value from the larger value. And when you're given the area under the curve and you're asked to find the x value that corresponds to that area, again, you have to take away the s. Take away the s that's between the norm and the I and v. But here, everything else remains the same. You're typing in the area to the left of that value. You're typing in your mean and your standard deviation. Finding the z value, this last one we're not going to talk about, but you can keep it for reference. We won't do any example, but if you do have any questions about it, don't hesitate to contact us at the Math Center. Okay, let's go ahead and see a problem where we will have to use a normal curve and not the standard normal curve. Now here we're given a problem that talks about Dunlop Tire, this company that manufactures tires. Now they have the property, the tires that they manufacture, the mileage on the tires lasts approximately 70,000 miles. Oh, I think there's a problem here. Let's see. Oh, I'm sorry, there is no problem here. That the data follows a normal distribution with a mean of 70,000 miles and a standard deviation of 4,400 miles. Now, what does this mean? It means that if we graph the data, we draw a histogram of this data set, that the data is going to look like a normal curve. We've talked about what the bell curve looks like with the tails and the peak in the middle. But notice that they did not say the data is standardized. It's not a standard normal curve. In fact, the mean is not equal to 0 and the standard deviation is not equal to 1. So how do we find the solution to the problems that are listed here? For example, the first problem, what percent of the tires will last at least 75,000 miles? Suppose Dunlop warranties the tires for 60,000 miles. What percent of the tires will last 60,000 miles or less? What's the probability that it's between 2.65,000 and 80,000? And finally, if they want a warranty, they want to give warranties to no more than 2% of their tires. What should the mileage be? And this is an inverse problem, number 4, or letter D. So let's go ahead and work through these problems. Remember the formulas that were given on the previous slide, and let's go ahead over to Microsoft Excel. Now here I've already set up a table that we're going to use. Let me just zoom, make this bigger, easier for you to see. Now, if we're asked for the area to the left, I've set up a little table that helps us to find the area to the left. But notice again that this is a little bit more detailed. When we're trying to find the area to the left of a standardized table, we didn't care about the mean and standard deviation. It was implicit that the mean was 0 and the standard deviation is 1. But here, because it's not implicit, we have to plug in what the variations in the mean and the variations in the standard deviation from problem to problem. Now, once we have that, what do? We're going to plug in a formula here because I want to set up a table. I don't want to type it in one by one for each of them. I have equals norm dot dist. Remember, no s. X is going to be this value here, whatever I put in that column, that cell. And then the mean is whatever I put in that cell. And I'm going to type the standard deviation and then true. We'll come back to this in a minute. I just want to type the formulas first. Now, what about the area to the right? Again, remember the area to the right is equal to 1 minus the area to the left. And the area to the left is given by the normal distribution function. So we have the normal distribution x, which is this cell, minus, not minus, comma, the mean, which is given there, comma, the standard deviation, and then comma, true. The area in between values, again, notice, or not notice, but remember that x0 is the smaller of the two, and x1 we're going to say is the larger of the two numbers. Now that's equal to the normal distribution for x, the mean, standard deviation, and true, and then minus the normal distribution, x for the smaller of the two, the mean, again, the standard deviation, again, and true, and close. Now let's go back to the problems, and or go back to the problem here and see what we should be plugging in. Now here in this problem, the mean is already given to us as 70,000 miles, and the standard deviation is given to us as 4,400 miles. Now for A, they're asking us what is a percent of the tires that will last at least 75,000 miles, at least 75,000 miles. Let's go back to our Excel spreadsheet and see how to solve this problem. Now, if it's at least 75,000 miles, that means that they're asking us the probability that x is greater than or equal to 75,000. This corresponds to being at least 75,000, x greater than or equal to 75,000. Now, if it's greater than or equal to 75,000, that means that this is finding the area to the right, because what's going to be shaded on the graph is anything to the right of 75,000. Now, how do we plug that in? Remember, that means that we're looking for this part. Remember that the mean that's given in this problem is 70,000, and the standard deviation is 4,400. In addition, the x value, now the x value, where does that come from? The x value is actually this value that's written here of 75,000. Now, we've already typed in the formula, so it's given here. The probability that x is greater than 75,000, or at least 75,000, is equal to 0.1279022. Now, problem 2. Problem 2 asks us to find the probability that x is less than 60,000. We don't have to go to see it. You should maybe have written it down, or you can go take my word for it. The probability of x being less than 60,000. Now, again, for this particular problem, we have a mean of 70,000. We have a standard deviation of 4,400. Our x value then is what is given, which is 60,000, and this is our probability. Now, for the next problem, the area in between. The area in between is our C part of the problem, and that gives us probability, or they're asking us the probability that x is between 65,000 and between 65,000 and 80,000. This is what they're asking us. Now, remember the mean, that hasn't changed. It's the same mean for the problem, 70,000 and 4,400 for the standard deviation. But what we have to focus on, what we have to remember here is that the x0, what we're using, is the smaller of those two numbers that are listed in the original problem. And then x1 is larger of the two numbers of, or 80,000. So what this probability represents is that what is shaded between these two numbers. So 86% of the tires are going to, 86% of the tires can last between 65,000 and 80,000. Now the final part, the final D part of this problem is asking us the probability that x is greater than x is equal to 0.02. this last thing is telling us the probability that x is greater than x is equal to 0.02. Now, this problem is a little tricky. It might be a little tricky, but what we have to do for this problem is we're going to, again, type in our 70,000. We type in our standard deviation of 4,400. Our probability of x value is 0.02. And then in this cell, in this box, we're going to type in the formula for the inverse, which is norm.inv, and we're going to type the area to the, not to the right, but the area to the left. So I'm going to type in 0.98 for this particular problem. And then the mean of 70,000. And then our standard deviation of 4,400. So again, please focus on, or notice here that instead of typing in a 0.02, I typed in 0.98. The reason why is that this problem is giving me the area to the right, but I need to type in the area to the left. So that means I'm going to take 1 minus this value here of 0.02, and that will give me my final answer. So 2% of the tires will last longer than 79,000. If I want to find the probability of x being less than 0.2, now what? Instead of typing in 0.908, I can type directly this value. And this tells me that 2% of the tires, only 2% of the tires will last less than 60,000 miles. So perhaps if the individual is trying to consider what is the cutoff for the warranty, now maybe he will say 60,000 miles is a cutoff for the warranty because only 2% of tires will last less than that. Now we're almost finished. Let's go ahead and go and do another problem to make sure that we've gotten this. Now this problem is talking about talking on a cell phone. And we're going to actually only do the first four problems. We're going to do the first 4 problems. So the first problem asks us the proportion of the time that it is at least 300 minutes. For the second problem, it asks us a proportion of the time where it will last less than 340. The third problem asks us between two values, 310 and 350. And then the last one asks us for the value that corresponds to the top 20 or the bottom 80. So let's go back to our Excel spreadsheet. Notice again, please here, that the mean is 324 and the standard deviation is 24. So again, this is not a standard. This is actually something that we might see in real life. Now, I'll go one by one. The first problem is not an area to the left problem, it's an area to the right problem. So for the first problem, they're asking us the probability that x is greater than 300. Now, for this, I have to type in my mean and my standard deviation. In fact, I'm just going to type it in for everything right now and then copy. Okay, so I don't have to type it again. Now for the, again, here I'm trying to find the probability of x being greater than 300. So for my x value, I type in 300, and this gives me my probability. Let's look at problem B. Now problem B asks us for the probability of it being less than 340. So I'm going to take away the 60,000 I had for the last problem. And I'm going to change that to 340. Now this 340 also will change here. And so I have this as my corresponding probability. Now for the C part of the problem, they ask us to find the probability of it being between 310 and 350. So I have 310 as a smaller number and 350 as a larger number, and that gives me 0.5808. Now let's go back up to the last part. And now the last part says that we're trying to find the probability that x is greater than 0.02. So this would represent the top 20 if greater than 0.02 and the bottom 80. Now remember that instead of typing in the probability of 0.02, I'm going to take in 0.98, 1 minus the probability, and that gives me 373.29. So 373.29 represents the cutoff between the top 20% and the bottom 80%. Now, as a review of what we have done today, we've talked about the normal curve. We've talked about the normal curve and how to use the Excel functions to find the area underneath the normal curve. Remember that the values along the x-axis are for the standard normal table are referred to as the z values, and those are what you would have to plug in into the formulas. Now, if there are any other questions that you might have or any problems that you might have with this section uh, in your class, please don't hesitate to contact the Math Center or the Learning Center or your professor uh, for additional assistance. Another thing to remember is that I have been using Excel 2013 to solve this, but this is also available in any version of Excel that is out there. I hope that you enjoyed today's lesson. I hope you found it interesting and useful. If you have any comments, questions, or suggestions, please don't hesitate to contact us. Thank you very much for attending. Have a wonderful evening.